Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture. And as I have told you in the last video lecture that in the next video lecture I will take up the problem based upon the nth order derivatives of the elementary functions. So these are the two problems written in which we have to find nth order derivative of 1 by 2x plus 3 and 1 by 3 minus 2x raised to the power 3. So we have to find nth order derivative, and I already told you that you don't need to remember any of the formulae. You just will write 2 or 3 derivative and will try to generalize in the examination also, like I will be doing it over here. Let us take the first one. It is, let us assume it as y. Fine. So we have to find the nth order derivative. So let's differentiate it both sides with respect to x. What we'll get? This differentiation will be minus 1, it will be 2x plus 3 raised to the power 2, and differentiation of 2x plus 3 will yield 2. Fine, this is first order differentiation. Differentiating again, because we have to generalize, and so as to generalize the nth order derivative we need at least 2, 3 or up to third order or fourth order as the requirement of the question. So we'll be differentiating again. What we'll get? Minus 1, it will be minus 2 divided by 2x plus 3 raised to the power 3, and 1 2 will be here, so it will be 2 into 2 will be nothing but 2 raised to the power 2. Fine. So now we will differentiate one more time. Let us see what happens. Differentiating again, minus 1 minus 2 minus 3 divided by 2x plus 3 raised to the power 4, and one more 2 will come, and here already 2 raised to 2 is present, and one more will come, so it will yield 2 raised to the power cube. So now let me try to establish the symmetry between these relationships. Can I write this relationship as minus 1 into minus 1? I am not going to write it as plus because I have to generalize up to nth order. You must give attention to it that I am not writing it as plus 1, but I am writing it as minus 1 raised to the power 2. So, and we are left with 1 into 2. 1 into 2 you know is nothing but 2 factorial. Fine. Into 2 square. Fine. Divided by 2x plus 3 raised to the power 3. Now can we write it something like 1 minus 2 minus and 3 minus? So can I write it as minus 1 raised to the power 3? Fine. And 1 into 2 into 3 is nothing but 3 factorial, and this will be the same, 2 raised to the power 3 divided by 2x plus 3 raised to the power 4. Fine. And now can I write it something like minus 1 raised to the power 1 into nothing is here, into 1 is 1 factorial obviously, and 2 raised to the power 1 divided by 2x plus 3 raised to the power 2. So now we will try to generalize and write the, you will put the 3 dots over here, you will put 3 dots also here and 3 dots over here. This shows that we are going to write something the generalized result. Now what will be the generalized? We have to find yn. So what will be its value? Look over here, give attention. When here is 1, here is minus 1 raised to the power 1. When here is 2, here is minus 1 raised to the power 2. When here is 3, here is minus 1 raised to the power 3. So whenever here would be n, so what will be here? Here will be minus 1 raised to the power n. Fine. Now again look at it. Minus when here is 1, here is 1 factorial. When here is 2, here is 2 factorial. When here is 3, here is 3 factorial. So whenever here will be n, here will be nothing but n factorial. Again look at it, when here is 3, 2 raised to the power 3, when here is 2, 2 raised to the power 2, when here is 1, 2 raised to the power 1. So it is obvious that whenever here will be n, so here will be 2 raised to the power n. Fine. Now again see, when here is 1, here is 1 more, 1 plus 1. When here is 2, here is 1 more, 2 plus 1. When here is 3, here is 3 plus 1. So whenever here will be n, here will be n plus 1. 2x plus 3 raised to the power n plus 1. So this is the nth order derivative of the given problem. So now you have seen that I didn't remember any of the formulae, but I was still able to calculate the nth order derivative successfully. So this question is important from examination point of view, and it is really very easy. You can see that I did nothing but I tried to find the element of symmetry between the various derivatives and then generalize the result for nth order. Okay, so now I will be taking up and solving the second problem. So for that I am going to take the second problem. Now this is the second problem. This is the problem number 2. Fine. So I have written it as this one and assume it as equal to y. Now I don't need to remember any of the formulae, but we have to differentiate it 2 or 3 times. We'll see, try to find the elements of symmetry. So you have to keep your head cool, you have to stay calm, you just have to follow the elementary fundamental principle, and the fundamental principle is that you start differentiating it and try to find the element of symmetry between the various derivatives, and that would help in generalizing and in writing the nth order derivative. So what I am going to do over here, I am going to differentiate both sides with respect to x. So what it will be? It will be minus 3. Fine. It will be 3 minus 2x raised to the power 4, and differentiation of 3 minus 2x you know is nothing but minus 2. I am going to differentiate it one more time. It will be minus 3. Look over here, I am not making it as plus or 3 into 2 as 6, because I have to find, you must remember that here my only motive is to find the elements of symmetry rather than multiplying and showing that we know the multiplication, and everyone I think of you knows the multiplication. Here we will not multiply, we will not write 3 into 2 as 6 or minus 1 square as a plus. So that is not going to land us anywhere, but that is going to create the trouble for us, and we will not be able to find any of the relation between the various derivative, and will not at all will be able to write the nth order derivative. So what we will do differentiate it one more times. Minus 3 as such, it will go up, it will be minus 4 divided by 3 minus 2x raised to the power 5. So one more minus 2 will come. So I am not going to write it as 4, I am going to write it as rather minus 2 square. Fine. One more time. Okay. Minus 3 minus 4 minus 5 divided by 3 minus 2x raised to the power 6 into minus 2 raised to the power 3. Fine. Now we'll try to find the element of symmetry. So look over here. If you see, here is 3, here is 3 into 4, here is 3 into 4 into 5. It could have been 5 factorial if it here were present 2, but here is no 2. So I can supply here 2 by dividing and multiplying both the numerator and denominator by 2. So what I'll do, I will be dividing and multiplying by 2. So one more thing I am going to do, I am collect these minus, these are very precious minus, so I am not going to write it as minus, but I am going to collect them minus minus minus. It will be minus 3. Very keep your head cool, stay calm and try to find. So I'm going to supply here 2. So I'm going to write it as 2, 3, 4, 5. Done. And as I have multiplied by 2, I'm going to divide it by 2, because we know this 2 and 2 will cancel out and we'll get the same this factor. Fine. So divided by, it will be as such 3 minus 2x raised to the power 6. Fine. And here I am not going to alter this one, this will remain the same. So can I write it as 5 factorial, because here 1 is obviously present, because here in 1 is obviously present, so I can write it as 1.2.3.4.5, which is nothing but minus 1 raised to the power 3 into 5 factorial into minus 2 raised to the power 3 divided by 3 minus 2x raised to the power 6, and here is in multiplication in the denominator by 2. Fine. So I'm going to do the same thing with this one also. I'm going to firstly collect minus sign, so it will be minus minus square. Fine. And same thing, 3 into 4, and 2 is lagging, 2 is lacking over here, so I have supplied 2, so I have to need to divide it. 3 minus 2x raised to the power 5 into minus 2 square. So what it will be? It will be nothing but minus 1 square into 4 factorial into minus 2 square divided by 2 into 3 minus 2x raised to the power 5. Fine. The same thing, minus 1 raised to the power 1. It will be 2.3 divided by 2. So divide and multiply by 2, and it will be 3 minus 2x raised to the power 4 is equal to, and here is also in multiplication we have minus 2 raised to the power 1. So this will be minus 1 raised to the power 1 into 2 into 3 is 3 factorial divided by 2, 3 minus 2x raised to the power 4 into minus 2. Fine. So I think we are done. So we have to try to find the elements of symmetry, and we'll generalize and write. So I'm going to put over here 3 dots, and you will also be putting 3 dots. Okay. That shows that the next term we are going to write is the result of the generalization. Fine. So here I am going to write it here, yn is equal to, look over here, 3 minus 1 raised to the power 3, 2 minus 1 raised to the power 2, 1 minus raised to the power 1. Whenever here will be n, here will be nothing but minus 1 raised to the power n into, look over here, 3, it is 5, 2 more, 3 plus 2. When here is 2, it is 2 more. When here is 1, it is 1 plus 2. So whenever here will be n, here will be n plus 2 factorial. Okay, fine. Done. When here is 3, minus 2 raised to the power 3. When here is 2, minus 2 raised to the power 2. When here is 1, minus 2 raised to the power 1. So whenever here will be n, here will be nothing but minus 2 raised to the power n divided by, in the denominator, let me generalize. When here is 3, here is 2, a constant quantity. When here is 2, here is 2, a constant quantity. When here is 1, here is 2, a constant quantity. So whenever here will be n, so here will be the same constant 2. Nothing raised to power n, nothing. It is a constant quantity appearing as a constant in each of the derivatives. So now next, when here is 3, in the denominator you see minus 3 minus 2x raised to the power 6. 3 more. Okay, 3 plus 3. When 2 plus 3, it is 5. Fine. When here is 1, 1 plus 3. So whenever here will be n, it will be 3 minus 2x raised to the power n plus 3. So this is the result. So can you write it yn as, if I write it as, instead of minus 2n, can I just write it as you will do it in the next step. I am going to make the changes over here. I am going to write this as it will be minus 1 raised to the power n into 2 raised to the power n. Okay, now I am going to collect this term and this term. What it will make? It will make a minus 1 raised to the power 2n. So I am going to write it over here, that I am going to make it as minus 1 raised to the power 2n. So what it will be? Minus 1 raised to the power 2n we know is it can be written as minus 1 raised to the power 2n. You see over here, minus 1 square raised to the power n. Minus 1 square is 1. 1 raised to the power n is 1. 1 raised to the power n means multiply 1 n times. You will again get 1 only. So this is 1. So this thing will be 1. So I am going to write the final result over here. What will be the final result? Yn will be n plus 2 factorial into 2 raised to the power n divided by 2 into 3 minus 2x raised to the power n plus 3. So one more adjustment if you want to do, you could do, otherwise you could leave the your answer over here. But if you still want to adjust this 2 over here, you can write it as n plus 2 factorial. This will go up and it will be 2 raised to the power minus 1. So this will be 2 raised to the power n minus 1 divided by 3 minus 2x raised to the power n plus 3. So this is the result. Okay. So you have to just go through each and every step. And how easy was it? It was really very easy and interesting one, because we don't need to remember any of the formulae, and yet we were able to determine the nth order derivative. And in the examination this question will come of 4.5 marks, this question, and you can see how easy it is. So in BSc first year, mathematics is really very easy and it is fun doing mathematics. So I have shown you how easy this question was and how simple it was. You just have to do the element differentiation, find the elements of symmetry, and then generalization. A simple generalization will yield the result. So in this lecture we have studied two important problems based upon the nth order derivative, and we have determined their nth order derivative and shown that we don't need to remember any of the formulae over here. Just differentiate 2 or 3 times and get the required result after generalization. So that's all I have from this lecture, and I hope that you will be able to understand this concept and this lecture. So very soon I will be with you with my next video lecture. Till then, take care, bye bye, see you soon. This is Dr. Rajesh saying goodbye.